Good morning, students. The next topic we are going to see is about the types of spectrum. There are two types of spectrum we are going to see. They are emission spectrum and absorption spectrum. The other topic we are going to see is about the Fraunhofer lines. Okay, so let us just see with this. First, when an object burns, it emits color. So we know that whenever you are making any object to burn, okay, suppose if this object is burning, okay, it will give off with some color, okay, and that it depends, it emits the electromagnetic radiation. So whatever it emits, that is called as what? That is a electromagnetic radiation, okay, which depends on the temperature. So temperature is at what heat it is burning, okay, so that much heat this electromagnetic radiation depends on. First, if the object becomes hot, so when this object is becoming little hot, what happens? It glows in the red color. If the temperature of the object is further increased, so if a temperature வந்து இன்னும் increase ஆயிட்டே போச்சுன்னா, what happens? It glows in reddish orange color. Okay. First, when it is hot, it glows in red color, and if the temperature is further increased, what happens? It glows in the reddish orange. So reddish orange color it will glow, okay, and becomes white when it is hottest. Okay, so when it becomes more hot, what happens? It becomes white. Okay, and the spectrum which is shown in this figure is called as a black body spectrum. So the spectrum which is being formed because of this, that is called as a black body spectrum அப்படின்னு சொல்லியிருக்காங்க. Okay, and it is a continuous frequency curve and it depends on the body's temperature. Okay, it will be always continuous curve. Yes, clear? Yes, so when the object is being burnt, what happens? It emits with the electromagnetic radiation. That electromagnetic radiation depends on the temperature. First, if the object is being heated, it is hot. Then it glows in red color. Further, if it is increased, it glows in the reddish orange color. And it becomes white when it is hottest. And this is called as a black body spectrum. Then, suppose if we allow a beam of light to pass through a prism, yes, already I think we know with the prism, is it not? So this you might have seen in your lab itself. In this prism, if you are passing the light like this, it is split into 7 constituent colors. Okay, so that white light is being split into 7 colors, and that can be viewed on the screen as continuous spectrum. So this we can view on the screen as a continuous spectrum, and this phenomenon is known as a dispersion of light. Okay, so when the white light is being split into 7 colors, that phenomenon is called as what? Dispersion. And the definite pattern of colors obtained after dispersion is called as a spectrum. So what is that spectrum is? We'll just consider with this VIBGYOR. Is it not? So VIB, that consists of 7 colors. Is it not? So that forms a spectrum. Okay, so that definite pattern of colors, that forms a spectrum, and the plural for spectrum is what? Spectra. Okay, and the spectra can be classified into two categories. So what are the two categories? Emission spectra and absorption spectra. So these are the two categories we are going to see here. So we have this prism. This prism is being passed with a white light. So this white light, when you see, it has been split into 7 colors. Okay, and this 7 colors forms a spectrum. Okay, and the plural for spectrum is what? Spectra. Clear? Then we are going to see with what is emission spectra. Okay, so what is the emission spectrum is when the spectrum of self luminous source is taken, we get emission spectra. Okay, self luminous source is from this source itself, it emits light. Okay, that is called as the emission spectra. The source has two characteristic emission spectrum, and this emission spectrum is divided into 3 types. So what are the 3 types of emission spectra is continuous spectrum, line spectrum, and band spectrum. Okay, so first, continuous emission spectra or continuous spectra. Yes, in this we are going to consider prism. Okay, the light from a bulb or arc lamp, it is being made to pass through the prism. So when it is passing through the prism, the at the other end what we get, that consists of the continuous spectrum. Okay, so light from any bulb, it is being made to pass to the prism. Clear? So if the light from a incandescent lamp, so we are considering incandescent lamp, it is allowed to pass through the prism, it splits up into 7 colors. As we know that any white light, if it is being passed through the prism, it is split into 7 colors. Is it not? Same way here also. And thus it consists of what? Wavelengths containing all visible colors ranging from what? Violet to red. As I've told you, Webjior is not so, it is violet to red. Then the spectrum obtained from the carbon arc. So these are all the examples of this continuous spectrum. So what are they? Is carbon arc, incandescent solids, liquids, and that gives a continuous spectra. Clear with this? So any white light, if it is being made to pass through the prism, that is split into 7 colors. Okay, and that 7 colors ranging from violet to red, that forms a continuous spectrum. Clear with this? Continuous spectrum. Okay. So, examples are the spectrum obtained from the carbon arc, incandescent solids, liquids, that gives a continuous spectrum. Clear? Then line spectrum. So what is the line spectrum is if any light which is from a hot gas, so we are considering a hot gas, then from that any light is made to pass to the prism, then what we obtain, that is called as what? Emission spectrum. That is called as a line emission spectrum. Clear? So first we have seen with a continuous and this is line. So what is the difference is in continuous we are considering with a incandescent lamp. Okay, here we are considering with a hot gas. Okay, so that is the only difference between continuous and the line. Yes, so suppose light from a hot gas is allowed to pass through the prism. So hot gas, it is allowed to pass through the prism, then the line spectrum is obtained. Line spectra are known as a discontinuous spectra. First one is a continuous one and this is a discontinuous. Why it is so is the line spectra are sharp lines of definite wavelength and frequency. So each one will have the definite wavelength as well as the frequency. So this line, if you see, it has some wavelength and it has some frequency. Same way the other line, it has some wavelength and also the frequency. Clear? These lines are the characteristics of the element, which means it is different for different elements. Okay, so characteristics of the element is what element it is. Based on that characteristic, it depends on. Okay, so the examples are atomic hydrogen, helium, etc. Clear? So light from a hot gas, when it is passed through the prism, line spectrum is obtained. It is not continuous. It has definite wavelength and definite frequency. Okay. Then band emission spectrum. So what is a band emission spectrum is it consists of several number of closely spaced spectral lines which are overlapped together to form a specific band which are separated by a dark space. Okay, so this has a number of closely spaced spectral lines. So these are the number of closely spaced spectral lines. என்ன இருக்கும் ஒன்று மேலே ஒன்று இருக்கும். Okay, which is overlapped together forming this specific bands. So it forms a specific band like this. Okay, and this spectrum has sharp edge at one end and which fades out at the other. So ஒரு edgeல பார்த்தீங்கன்னா இது வந்து ஷார்ப்பா இருக்கும், next edgeல இது வந்து faded out ஆன மாதிரி இருக்கும். So where it is sharp and where it is faded out is where all the lines are close together, it seems to be as sharp, and where they are far apart, it seems to be as faded out. So such spectra arises when the molecules are excited. So when the molecules are in the normal state, this spectra will not arise. It arises only when the molecules are in the excited state. Clear? Then the band spectrum is a characteristics of the molecule. Hence, the structure of the molecules can be studied using the band spectrum. So whatever the structure of any molecule, that can be studied with the help of this band spectrum. And what are the examples is spectra of hydrogen gas, ammonia gas in the discharge tube. Okay, so these are the examples of band spectrum. So band spectrum consists of number of dark lines, okay, which seems to be as which is dark at one end and faded out at the other end. Clear? Next we have the absorption spectra. So what is an absorption spectra is when the light is allowed to pass through a medium or an absorbing substance, then the spectrum obtained is called as a absorption spectra. Okay, light is passed through any medium, so we are going to pass the light through the medium, or this medium can be an any absorbing substance or absorbing substance குள்ள நம்ம light pass பண்ணோம் அப்படின்னா then the spectrum obtained, that is called as what? Absorption spectrum. and it is a characteristics of absorbing substance. So என்ன absorbing substance எடுக்கிறோமோ அதை வச்சு தான் இதோட characteristics இருக்கும் அப்படின்னு சொல்லியிருக்காங்க. Okay, so when a light is allowed to pass through the medium or an absorbing substance, then the spectrum obtained is called as what? Absorption spectrum, and it is a characteristic of absorbing substance. Okay, it is of three types, same way continuous, band and line. So first one, continuous spectrum. When the light is passed through a medium, it is dispersed by the prism. Okay, so when the light is passed through a medium and it is being dispersed by the prism. Okay, so when you are passing through the prism, it get dispersed. Okay, for instance, when we pass white light through a ப்ளூ கிளாஸ் பிளேட். ஸோ இது வந்து ஒரு ஒயிட் லைட் எடுத்துக்கிறோம். ஓகே, இந்த ஒயிட் லைட்டை ப்ளூ கிளாஸ் பிளேட்டில் அனுப்புகிறோம் அப்படின்னா இட் அப்சார்ப்ஸ் எவ்ரி திங் எக்ஸப்ட் ப்ளூ, பிகாஸ் ஒயிட் லைட் கண்டைன்ஸ் வாட்? ஒயிட் லைட் கண்டைன்ஸ் ஆல் த கலர் ஃப்ரம் வயலட் டு ரெட். ஸோ வயலட் டு ரெட்டுக்குள்ளே இருக்கிற எல்லா கலர்ஸும் ஒயிட்ல இருக்கும். ஸோ அப்போ இட் ஆல்சோ கன்சிஸ்ட் ஆஃப் வாட்? ப்ளூ கலர், இஸ் நாட்? ஸோ வென் யூ பாஸ் திஸ் ஒயிட் லைட் த்ரூ திஸ் ப்ளூ கிளாஸ் பிளேட், what happens? It absorbs all the color except blue. So blue தவிர மீதி எல்லா கலரையும் என்ன பண்ணிரும்? இது வந்து அப்சார்ப் பண்ணிருக்கும் அப்படின்னு சொல்றாங்க. So this is an example of continuous absorption spectrum. Clear? So when a light is passed through a medium, it is dispersed by the prism அப்படின்னா அப்போதான் என்னது? We get continuous absorption spectrum. Next is, for instance, when we pass a white light through a blue glass plate, it absorbs everything except blue. Clear? So next is line absorption spectrum. When the light from a incandescent lamp, so ஒரு incandescent lamp எடுத்துக்கிறோம், அதுல இருந்து it is passed through a cold gas. Okay, so the medium which you are considering here is what? Cold gas. So in the cold gasல இந்த light pass பண்ணோம் அப்படின்னா what happens? The spectrum obtained through the dispersion due to the prism is line absorption spectrum. So இதுல இருந்து நம்மளுக்கு disperse ஆகி வர light தான் என்னது? Line absorption spectrum. Clear? So when the light from the incandescent lamp is passed through the cold gas, okay, then we obtain with the line absorption spectrum. Next is, so this is light from the incandescent lamp. This is being passed, this is incandescent lamp, this is cold gas, and it is made to pass through the prism. Then the spectrum obtained is called as what? Line absorption spectrum. Okay, then similarly, if the light from the carbon arc is made to pass through the sodium vapor, a continuous spectrum of carbon arc with two dark lines in the yellow region. So carbon arc லந்து பாஸ் பண்றது, it is made to pass through the sodium vapor. sodium vaporல பாஸ் பண்ணோம்னா என்ன ஆகும்னா it gives with a continuous spectrum. so continuous spectrum இருக்கும் with two dark lines, ரெண்டு dark lines, அதுவும் எந்த ரீஜன்ல? ஒரு yellow regionல. so ஏன் yellow regionல அப்படின்னா, since the sodium is yellow in color, so we'll have a yellow background with two dark lines. Okay, so with two dark lines in the yellow region is obtained. Okay, so this is for line absorption spectrum. Clear? Then next we have band absorption spectrum. Okay, so in band absorption spectra, when the white light is passed through the iodine vapor, so and the dark bands on the continuous bright background is obtained. Okay, so ஒரு white light என்ன பண்றோம்னா ஒரு அயோடின் வேப்பருக்குள்ள சென்ட் பண்றோம் அப்படின்னா we are getting a dark band. Okay, so dark means what? Black color. Okay, so black with white background. so இதுதான் ஒரு white background. இந்த white backgroundல நம்மளுக்கு ரெண்டு dark lines கிடைக்கும். This type of band is also obtained when the white light is passed through. so இதில் அயோடின் வேப்பரில் மட்டும்தான் பாஸ் பண்ணணும்னு இல்லை, we can also pass through what? dilute solution of blood or chlorophyll or certain solution of organic and inorganic compounds. so நம்ம அயோடின் வேப்பரில் மட்டும் இல்லாமல் இந்த மாதிரி சொல்யூஷன்லையும் நம்ம வந்து அனுப்பணும் அப்படின்னா will be getting with a dark bands with a continuous bright background is obtained. Clear? so next is Fraunhofer lines. so these are all the Fraunhofer lines. so what are they? is when the spectrum is obtained from the sun is examined. so from the sun we'll be getting a spectrum, is it not? And if that spectrum is being examined, what happens is it consists of large number of dark lines. So இதுல வந்து நிறைய dark lines இருக்கும் அப்படின்னு சொல்லியிருக்காங்க. These dark lines in the solar spectrum, அந்த dark linesக்கு பேர் தான் என்னது? Fraunhofer lines. Okay, when the spectrum from the sun, so நம்மளுக்கு sunல இருந்து வர spectrum, if you are going to examine, what happens, it consists of large number of dark lines. அந்த dark lines எந்த spectrumல இருக்கு? இது வந்து solar spectrum. So why are saying it as solar spectrum? Because it is been obtained from the sun அப்படின்றதுனால it is called as solar spectrum. So if you are just viewing this solar spectrum, we'll have a dark lines, and that dark lines are called as what? Fraunhofer lines. Okay, the absorption spectrum for various materials are compared with the Fraunhofer lines in the solar spectrum. So absorption spectrum in the Fraunhofer lines எப்பவுமே we are just comparing அப்படின்னு சொல்லியிருக்காங்க. Okay, so clear with this? What is Fraunhofer lines? Yes, thank you.